Alright, I've had trouble with my mic getting unplugged somehow on the video, so here's a redo of this with sound. Alright, so I'm setting up the rectangular angle for the cattle, where one side is the river side, so he's not going to need any fence here. Then he has the fence that goes, so there's his fence. And he has 3,600 feet of fence. Alright, one side is the river, so he only needs to have fence on both of these, which those are the same distance. So those would be the vertical sides, and that would be the one parallel to the river. Alright, so he has 300 feet of fence total, so the x plus y, that perimeter without the river, has to add up to 3,600 feet. Alright, so 2x plus y has to add up to 3,600 feet. Alright, that's what we have to have. We want to maximize area. Alright, and so area, remember, is length times width, so it'd be x times y, and that's what we want to maximize. And remember, area has to be positive, and all my values have to be positive. Alright, so area is x times y, and why they gave us this other piece of information is because I have to get rid of one of the variable parts. Alright, I'm going to get rid of the y. I'm going to solve that first equation for y. So I'm going to go over here, my 2x plus y equals 3,600. I'm going to solve this for y, which means I'm going to move the 2x over. And so I know y has to equal 3,600 minus 2x, and that's what I'm going to substitute up here in my area equation. So area is going to be equal to x times 3,600 minus 2x. Now I've got my quadratic I can solve. Right, and that's what I want to optimize. All right, I want to maximize that area. And so I'm going to distribute multiply through my x. And so area equals 3,600x minus 2x squared. I know it's a parabola that it's opening, right? This is a parabola, right? It's because it's a quadratic. It's a parabola that opens down. So I know if I find that vertex, that's my maximum. Right? And so that's what I have to find. And so there's a few ways. You can actually solve it graphically. I'm going to solve it using the vertex equation. And so I know the x value for the vertex is the opposite of b over 2a. Opposite of b, not negative 2. Opposite of b over 2a. B is my 3,600, so it would be negative 3,600 over 2 times negative 2, because negative 2 is my a. And so that simplifies to 900. Alright, so my x, so this side of my rectangle is 900 units. Alright, well, what's the y? Well, I take that 900, plug it into that equation there, and find my y. So y equals 3,600 minus 2 times 900. And so y comes out 1,800. And so this side has to be 1,800. Alright, so we want to find the dimensions of the rectangle to give the maximum area, and so there's my dimensions. Didn't ask me to find maximum area, but maximum area, if I wanted to, would be x times y, the 1,800 times my 900, and the maximum area would come out a really big number, feet squared, if you wanted to know it. Now, it didn't ask for it, but that's what the maximum area would be. That's found if his rectangular field is 900 feet by 1,800 feet, where the 1,800 feet is the one parallel to the river side. Alright? This would be perpendicular to the river side. And that would be optimizing my area. Alright, so there's the maximizing area example with sound. Hopefully I'm going to check and make sure it is. But there's the one with, and I went through it a little faster. You could probably watch my other video and figure out what I'm doing as well. But again, we want to optimize, which means we want to find a quadratic equation When I find my quadratic equation, maximize and minimize should be my vertex. You could find the vertex graphically, although I think in this case it's just as easy to use the vertex formula, which is what I did. And then we have to find all the parts they're asking for, and so they did ask for the length and the width. We found the length was 900, the width was 1800, and that would optimize my area, which again, I didn't ask for maximum area, but if I had, the maximum area would be that value. That's the size he needs to make his field. Alright, there's that example all done.